Hello everyone, welcome back. And today we are going to see an interesting project, NLP localization. Oftentimes what happens is that popular Hollywood movies are remade or adapted sometimes into a different country or region. For example, an English movie could be adapted and remade in Hindi or Korean or Chinese, etc. So this general concept is called localization. It's not just about movies, but maybe there is an ad or maybe there is some content or advertisement and they are adapted to a different region or country. The general concept of adapting any content to a specific country or region is called as localization. And in our course, we are going to take an interesting view of this, which is we will do localization automatically using natural language processing techniques. We have learnt about word vectors, named entity recognition, etc. So how can we use word vectors and named entity recognition NER and automatically do localization of any given movie script into a different country or region? And we are going to exactly see that. And this could be another feature in our moviepro.ai app, where with one click you can take any movie like Batman Begins or any other popular movie and directly adapt or localize it to a different country. So before even solving that, let's miniaturize the problem and just take the example of edtech content localization. So instead of dealing with the whole movie plot, let's just deal with one or two sentences and see how localization is done, and then we can use a similar algorithm and concept to localize our movie plot. So first of all, assume that there is an edtech company that is in US and it is expanding to India. So what happens is that they would have already created lot of content, for example some math questions or English, science, etc. questions. Of course the curriculum differs quite a lot, but oftentimes let's say they already have a question bank that they want to localize and adapt it to let's say Indian subcontinent, or if they are going to China, probably to China or to South Korea, etc. So usually the examples in US, let's take a small example of grade 2nd math problem in US. If it says Frank lives in San Francisco and Elizabeth lives in Los Angeles, if the flight time is 2 hours, when will Elizabeth reach Frank if she starts at 8 a.m. in the morning? A very simple question. The point here is not about the question, but rather about the concept, how we are going to automatically use NLP to localize this question to an Indian context. Now what happens is that this question is not directly usable in India because there are a lot of names, for example San Francisco, Los Angeles, Frank, Elizabeth, and similar things that could be very local to USA and not familiar with Indian students, right? So if you want this question to be more practically oriented to Indian students, you need to change the names, places, etc. that you encounter in this to Indian names, etc. So what you can do is, for example, replace Frank with Sanjay Verma and San Francisco with Bangalore and Elizabeth with Rekha and Los Angeles with Mumbai, etc. So if there is a human who is involved in this, they would have idea to find relevant place names and person names and adapt them to whichever country they are in. They are creating the questionnaire for example here India. But let's see an interesting use case how you can use NER, named entity recognition, and also word vectors to actually localize this and automatically convert the US question into an Indian adapted question. let's see how we can use NLP to go forward. So first what we'll do is we'll extract named entities. For example, you can see here Frank is a person, so you can use any library like Spacey, etc., and extract the named entities. Here Frank is person and Elizabeth is person, and San Francisco and Los Angeles that you see in orange are location. So GPE stands for geopolitical entity, which simply means location. And there are other things that are identified, for example number, 2 and 8 a.m. in the morning is time. So entities could be anything that you have trained the algorithm for example organization, person, location, time, number, currency, etc. But what we'll do is we'll extract entities that need to be localized. For example, number 2 and 8 a.m. in the morning time, they don't need to be localized. We only need to localize the names and locations. So step 2 after extracting named entities is filtering only those named entities that need to be localized. For example, in our use case, we are keeping only locations and persons, those named entities, that is person and GPE, and we are ignoring time and cardinal numbers. So from these named entities that are identified, we filter the entities that we want to localize, and we get finally Frank, San Francisco, Elizabeth and Los Angeles. These are the only things that we need to localize. Now step 3 is actually very interesting, which is we have seen that word vectors, when trained with large corpus of data, for example if you are training it on the whole Wikipedia dataset, then it would see names, places from all over the world, and it has been trained on all of that, right? So word vectors, as we have seen previously, they preserve real world relationships. For example, king minus man plus woman is queen. All such relationships are preserved in word vectors. That is, you take the king vector and you take woman vector, add them, and then subtract the man vector from it. You get back a vector, and if you query all the word vectors to find the similar vector, you will see that the word vector that corresponds to queen is the most similar. So essentially real world relationships among words hold true in the word vector space. And interestingly, what you can do is you can apply similar logic and proceed ahead with Frank minus USA, that is Frank word vector subtracted with USA word vector and Indian word vector added. You get back a word like Sanjay Verma. We are going to see that there is Google News word vector, which is trained on quite a lot of data, and if we use the word vectors from Google News, automatically if you give Frank, USA and India and follow this relationship, you'll get back Sanjay Verma. And if you take San Francisco and subtract USA from it and add India, you'll get back Bangalore. Similarly, Elizabeth corresponds to Rekha and Los Angeles comes out to Mumbai. This almost looks magical, but we are going to see it in code and really believe it. And the step 4 is pretty simple. Wherever Frank comes, just replace that with Sanjay Verma. Wherever San Francisco comes, replace that with Bangalore, and the same for rest of them. So with step 4, you are able to convert your original sentence Frank lives in San Francisco and adapt it to Indian context automatically by replacing the named entities. And what can you do with this? Similarly, you can localize or adapt any movie plot. For example, if you just get Batman Begins, you can similarly identify all the locations, person names, and automatically use word vectors to find their corresponding names and locations localized to any different country. You can build this as a feature for moviepro.ai, where you can take any movie plot And in our Streamlit app, you can write the code such that with one click the given movie plot is localized to a different country. And what that could do is that it can serve as a good starting point for directors who are looking to adapt a Hollywood movie to a different country. The new director can use the localized script and make some modifications. Of course, since these are NLP and AI algorithms, they are not perfect, but they can give a good starting point where directors can work on the modified script and localize it more. Of course, true localization means you need to even adapt context and everything, but at least in our setting we are just converting persons and locations and automatically localizing them using NLP. Some of the things might look magical to you, that is it even possible, but trust me and we will see it in code in the next section.